In this video, I'm going to solve a modulus inequality using a graphical method. So the first thing I'm going to do is I'm going to draw the graphs of the functions on either side of the inequality. So I'm going to start by drawing the modulus of 2x minus 5. So to do this, I'm going to work out what my original y equals 2x minus 5 would look like. So I know that the graph of y equals 2x minus 5 goes through minus 5 on the y-axis, and I know that it goes through 5 over 2 on the x-axis. Now, it's going to be a straight line graph with a positive gradient. Now, because it's a modulus, what happens is the part of the graph that would ordinarily be underneath the axes gets reflected and becomes positive. So it's actually going to go through positive 5. Now let's do the same for y equals 3 minus x. So this has a negative gradient. It's going to go through 3 on the positive axis. And it's going to go through 3 on the horizontal axis. So this time it's going to go downwards, and the bit that would have been underneath the axes will be reflected up, and there is my two functions. So what we're looking for in our graphs is when the modulus of 2x minus 5 is bigger than the modulus of 3 minus x. So this means we're looking at when the blue graph is above the red graph, and that happens on the left-hand side, but it also happens on the right-hand side. So what we need to find is these 2 points of intersection so we can form our inequality. Now, the intersection on the right-hand side is formed from the part of the graph that's actually from the positive. It's from the part of the graph that's not been reflected. So I can find these solutions just by setting the graphs equal to each other and solving in the usual way. So this point of intersection here is 8 over 3, and I know the section of the graph I want is when x is bigger than 8 over 3. Now on my left-hand side, I've actually got the reflected part of the graph 2x minus 5. So this means I'm going to use the negative of 2x minus 5 when I solve. So now I'm going to expand and tidy this up. Looking at my graph, the region that I require is less than this point of intersection, which is x equals 2. So my inequality is going to be x is less than 2.